let's get started. Good afternoon, IA. It's great to see so many students. And we need a little bit of a cheering exercise first of all. I want to hear from you. All right. So the passion is there, that's good. The passion for engineering is there. And you have 7 passionate engineers on stage this afternoon. So what we really want to do is share our experiences with you. And we do it first here in the room for an hour roundabout. And that's to be interactive, right? We've received your questions up front and we're going to pick some of them and answer them, but we want to hear from you. So we will exchange and you will have a chance to ask more questions. If you want to get at any point even more specific, more detailed, then we are also all going to be available for half an hour at least afterwards the session. And please feel free, right, to mingle, step up to us, and we'll keep talking then. So let's get started with an introduction. We have quite a diverse panel, as you can see, with engineers from all sorts of backgrounds. And Carrie, why don't you kick us off with a quick personal introduction?
Hi, everybody. Can you hear me? Maybe a little higher. Carrie Okma. I'm a chemical engineer. I have a degree from Illinois Institute of Technology. Yes, Okma, I see somebody mouthing. Yes, there is a relation there. I graduated also with a master's degree at University of California, Davis. I currently work at Stellantis, which is an auto company, Chrysler, Jeep, Fiat, PSA. And my field is vehicle electrification, so I lead a team and we source all the batteries, source and develop all the batteries for the electric vehicles.
You want to continue right away?
Yes, thank you, Carrie. And can you hear me, first of all? Yeah. Okay. My name is C.Eng, and I received my PhD in chemical engineering from University of Manchester in England, and quite far away from here. But I joined GM in year 2000, and currently I'm leading a group of engineers and developing fuel cell components. Nice meeting you.
All right, so we kept it simple for you, right? We have 2 chemical engineers on that end of the podium. And let me ask you right away, what brought you into engineering, into chemical engineering?
So, in my case, even starting in middle school and high school, I've always been very passionate about the environment, about combating climate change, about preserving the planet for the next generation. And so that really started me into chemical and environmental engineering, and from there into vehicle electrification.
All right, okay. You know, when I was, I think I decided when I was younger, right, and I was very curious about things, how things are made and why the way they're working, right? For example, with this plastic bottle, I was curious, okay, how this plastic bottle is made. Now I know it's injection molding, but I was very curious and where the material is coming from. So that kind of led me to chemical engineering. And then later on in my career, and I shared the vision from Carrie, right? We can use technology to really help the society to address many issues, right? Like offer clean energy solutions or develop like autonomous drive vehicles to reduce traffic jams and save lives.
Thanks, Zhang. Okay, we get to a new background, right? We got Chris from mechanical engineering, and Chris, let us know what you do.
Yeah. Hi, good afternoon, everyone. My name is Chris Mays. I work at Borg. I'm Chief Engineer in our Corporate Advanced Systems Engineering Group. I'm a mechanical engineer. I'm a chartered mechanical engineer, which means I've done extra training in the UK, which makes me a professional engineer with that qualification. I studied at the University of Southampton and took a master's in automotive systems engineering at Loughborough University. And to answer the question, in the same way, I was really interested in how things worked. I didn't used to think how were things put together. I used to take them apart to find out and then think, how do I get this back together? And really loved engines and cars when I was younger. And really was really fortunate to be able to work in automotive systems and particularly engine engineering. I've done a lot of work on engines in my time.
Thank you. Go along the line, Raghu. You want to continue?
Sure. Can you guys hear me okay? Yeah. All right. So, first of all, thanks for being here. Really appreciate it. Hopefully you'll get something out of this session today. My name is Raghu Gummaraju. I actually work for BASF, which is one of the largest chemical companies in the world. It's a German company. I manage the product portfolio for all the paint that goes on refinish for cars. So if you have a car, if you get in an accident, you take the car to a collision center, right? The paint that we sell at the collision centers is what the business I manage. My engineering background, I'm a polymer science and engineering major. I have a PhD. Prior to that, I have 2 degrees in actually physics. So I'm a physics major. Now I'm doing a business role. Now, why did I get into material science and engineering? I've always been fascinated about how things are put together, in the sense that from a material perspective, kind of using the same example as you did, Jan, about plastic bottles and cars and how are the steering wheels put together, how the instrument panels put together. So that kind of always fascinated me, and that's why I chose material science and engineering. It's a very interdisciplinary field. So you can't just be a material science engineer. You have to know a lot about all the other sciences. So that is another reason why I chose that field.
You will see we really tried to get a diverse panel together. And Garth, when you talk about your background, I find it fascinating. And so, tell the students.
First, thanks for having me. This is a great opportunity. Is this thing on? Can you hear me? Okay, great. So where I am right now, I'm working at General Motors in autonomous vehicles, so driverless cars, and they're system safety engineer. And I've been doing that for about almost 5 years now. Great job, absolutely love it. I'm not a systems engineer. So my background is ocean engineering. That's where I first came out with, and that's my bachelor's. I graduated from the United States Naval Academy. And going through there, to start off, why I chose ocean engineering. And for those unfamiliar with ocean engineering it is really anything stationary in the water. So when you look at building dock systems, oil platforms, things of that nature, that's in ocean engineering. I did it because I absolutely love the ocean. I knew if I was going to be in engineering, it will always take me closer to the ocean itself. And hence the reason why I went to the Naval Academy as well, because I'll always be at the beach somewhere, right? So I went ocean engineering through the academy, and another side bit too is that my older brother also did ocean engineering at the academy, so I got all his old notes too, which got helped out as well. So I went through there and actually went submarines, in the submarine service. And the thing about submarine service, I don't care so much about ocean engineering, but nuclear engineering. So I went through the nuclear engineering school and became a nuclear engineer through that. And I've been in submarines, living around the world for pretty much 20 years on. From that point, I was able to get masters. I've got 3 masters through the Navy, the last one being an MBA out of United Kingdom, Borg. So I know what you came through from the UK. And honestly, I absolutely love my life. I love my opportunities and serving my country and doing that with my family and really going around the globe. Once again, to cap off, why engineering? Engineering from the get-go is just the best, I believe, education you can get into, because it forms the basis of the mind thought of the engineer. Because when people come to the engineer, they know they have someone that can solve any problems, that drive to solve that problem. No matter what faces them, they put it in front on their desk, and that's all they think about. So it's that kind of the mindset of an engineer, and makes you not necessarily a great engineer, it makes you a great manager, it makes you a great business person, makes you a great marketer. So really, it's just a stepping point for any career you really want to go off. I have a lot of peers who went off and became dentists. They went off to go become doctors. I have a lot of people I graduated with who are CEOs of companies, all engineers. So it's a great stepping point from that point on.
No, thanks for sharing. I mean, we might be biased, right? But I think you have a very important message, Garth, out of your resume, out of your experience. And that is the career path is never necessarily a straight one, right? And you see, going from marine into nuclear, into now doing autonomous vehicles, that's quite a route. And I think we are all here also to share these experiences with you and encourage you, right? Yep, you should work hard into the next steps and use the right study and the right university. But we also want to take a little bit fear away from you in the sense there is no right or wrong when it comes to putting the first step forward into study or into professional life. And Garth, I mean, you really exemplify that very much. Don.
Thank you. So Don Finney, started my engineering career in middle school writing software. That led me to taking things apart as an engineer, not necessarily putting them back together, but taking them apart and figuring out how to make them, different. I went to Kettering, or I actually graduated from GMI. It's now called Kettering, north of here, about an hour. Also have my MBA from Oakland. My degree is electrical engineering. But I focused on software and multidisciplinary things. I've been involved in mechanical, chemical, industrial, so it leads you down a very varied path as you take whatever opportunities tend to come your way. And I really like engineering because I like to make cool products. The stuff I've worked on, navigation systems, I'm currently working on a mobility solution. I work for a cybersecurity company called Irdeto in Pontiac. We have a platform that goes on heavy trucks to offer fleets a better way to manage their vehicles. We talked, some of the proud moments. Engineering has allowed me to achieve a couple life goals. I've already been fortunate enough to be a CEO of a startup. I ran that for several years. I've also been able to achieve patents with my name on them. So from a development perspective and inventive perspective, engineering offers you a lot of different things you can really sink your teeth into. And for the car lovers in the room, I am the rightful driver of the red Cadillac that my daughter likes to claim as hers.
Good. No, my name is Fischer. I'm also an electrical engineer, so chemical, electrical on that area. And I work with an automotive supplier. It's a German company, ZF. We are the number 3 in the world. And we deal with technology and all the latest trends, be it electrification, be it autonomous vehicles. What got me here? Well, I grew up in school and was always pretty interested in maths and physics, and then I started programming pretty early in life and started developing software, even selling some software during high school. And when it comes to choosing my study, I went for electrical engineering, because at the time that was when automation started. So you could do things with electronics and software that had to be done by human beings before. I found that fascinating, and that's why I said I do it. My first part of study I did in Germany, Technical University of Darmstadt. And then I also came over to the States for a year and went to UC Berkeley to get my first experience with America. And like you said, right, these experiences, they shape you and shape me as a person, shaped our family. I mean, Anna and Sophie have been here, and they don't have this strange dialect that their dad has, because they just grew up here in the States. And so my engineering career also took me really on a nice route through the world and made us proud American citizens of the world. So let's get started. Many of you have questions. So how do we get there, right? How do we prepare well in high school really for an engineering career? And that's a question I want to open up to the panel. Raghu, I don't know, you want to take a shot at it? If you have choices in high school,
Sure.
what do you do?
Can you guys hear me? Yeah. I think the way I look at it is everybody's journey is different, and your starting point in high school is pivotal because that's kind of where you start learning sciences. And you also, in my opinion, think about problem solving potentially, right? So whatever interests you, pursue that. But really, you don't really need to know as a senior what is that you want to be, but always pursue what really interests you, intrigues you. But the reason I pursued what I did is I've always kept an open mind to understand, what is more important to figure out, to solve problems, to understand where my interests are leading to. So kind of that's how I look at it. Like, how do we decide in high school where you guys are? Have an open mind, think about what really interests you, and focus on that now.
Good. And how about you? I ask you specifically because, we are a diverse panel, but as a matter of fact, there's probably still more male in engineering than female. So what got you into the female role of an engineer with all that strength?
What, from my experience, right, I share some of the, my observations. So I regard as boys or girls, right? And if you, think about your hobbies, right? And even, look around in your household, let's think about how the things you learn, like, science, engineering, play the roles in the household for the hobbies, right? And for example, I'm a girl, I like cooking, right? Then if you think about cooking, it's actually like a chemistry process, right? You can have a different ingredient, you do experiments, and you develop methodology to do, to enhance the cookies. And use another example, like, if you like biking, right? Then you're thinking, okay, how do I ride my bike in the long distance, right? Not get tired. Then you think about, the things I can do improve efficiency, like my clothing, right? Should I wear something aerodynamic, so reducing the drag coefficient? So those kind of, you look around you, this is everywhere about engineering. It's not really scary at all. And then, if you know your interest, then you deep dive into those things, you realize you can use like fundamental principle to explain those things. And that kind of drive you deeper into more interest. I think that can lead into find out what's your true passion. That's kind of the growth, for myself. And, engineering is everywhere, right? It's not scary at all. And then, once you start looking around, then you, it's pretty cool. Actually, you can use those principles to explain daily life, right? Then, once you get into deeper studies, you can use them to change the world, actually.
And how do you find the right field of study? I don't know who wants to chime in. Don, how do you determine that when you're in high school?
So mine was chosen because the school didn't offer computer science. So I went to the next closest thing, which was electrical engineering, which sounds a little bit crazy because they've split since then. But for me, it was, what are the things that interested me? But also, as importantly, what are the things that didn't interest me? For me, I was not a chemical person. I knew that chemistry and bad. Nope, not doing it. Physics was more interesting to me. And I was between electrical and mechanical. The thing is you take classes in both. You take classes across all the disciplines. So if you sort of pick one that's close enough, and then as you get into it, you take the classes that are more along what you like, and then that just starts to guide your path. Because if you're to try to choose it today, it changes tomorrow.
I have some bad news for you. Chemistry is physics.
Well.
But I think my advice is not to be intimidated. So I think particularly with math and science, I think unfortunately sometimes even more particularly with women, but not just women, with everybody, people tend to feel intimidated. Oh, math is so hard, science is so hard, it's not for me. But it's nothing to be intimidated by. You just need to go into it with the right attitude and open attitude, and then you can discover if you really truly like it or not, but not relying on preconceived notions of, oh, math is too hard, science is too hard, it's too difficult. And in terms of like a specific engineering field, I would say, honestly, it doesn't matter as much as you might think it does. I have a lot of electrical engineers doing chemical engineers doing electrical engineering. I have chemists in my group. You can really mix it up once you go into engineering. So important if you want to go into a science career that you start off in some kind of science path, but in terms of a specific, physics, engineering, chemistry, there's a lot of overlap in those fields. You can definitely wander around.
Same theme again, right? It doesn't really matter 100% where you get started.
Yeah.
So let's do a quick poll. Who already is convinced he or she wants to go into engineering? Those will be in the right range. And that's the first group. That gives us an idea. Oh, wow. Okay, team building happening amongst the future engineers already. All right, next question. Who's considering engineering? Shouldn't be the same group, but say, not quite sure, but definitely something to look at. So I would say, what, 25% altogether, maybe in that group, right? 25, 30% convinced already or interested. So with that, I think we should turn it over to you and say, from where you are right now in your school career, right? With looking forward into university, into the right curriculum to choose. What are your questions? What do you need to know on that step from school into college? Let's see if there's any questions. So we have a mic for you, or how does it work now? Or you yell at us?
Stand up and use your big voice. You can come up front if you want. Engineering experience, lawyers, that
You say if you get or don't get engineering experience versus, during high school, is that going to impact your chances, opportunities, career?
No.
Chris, why don't you speak to it?
I'll give one example. We had an intern applying and had no experience in high school, looking to encourage you to select that person. And you talk to them, and the reason they really got into engineering was they saw their friends at university and they were really interested in what they were doing, and they realized that that was more aligned to what they wanted to do than what they had been studying. And they had more of a passion for engineering than some people who do robotics and a sequence of steps through high school to get ready. And people are looking for the passion. So you're not looking for the experience and showing that you've gone down the road, but you've got to show the passion. Why do you want to do engineering? Why particularly our company, if you're applying to our company? What is it about our products you like? What is it about the process you like? And you have to sort of convey that a career is a long time. It's 40 years if you're unlucky, maybe longer if you're really unlucky. And you've got to really enjoy it. You can't be doing a job you hate for 40 years. You've really got to enjoy it. And when you see that passion from someone who really engages and enjoys it, that's worth more than having demonstrated excellence in engineering when you're young. So never be put off by not having the experience. And then you can be like me and have days where you think, I'm doing something really fun and I'm getting paid for it.
Good. Good question. There's another one. Good.
You have to take a lot of physics classes.
So the question is, do you have to take a lot of physics classes to become an engineer? Garth, what's your experience?
Well, my college was a little different because if you're a government major or literature, you still had to take electrical engineering. Well, everyone's an engineer kind of coming out of it, but it's different types of it. We call it wires or cables. The core engineers had to take the cables portion of it. But the key thing, even though I'm an ocean engineer, yes, I took oceanography as one of my courses, but I took the whole spectrum of engineering when I was there. So I did, an entire year of chemistry. I did an entire year of physics. You go through in system engineering. I did an entire year of system engineering. So even though my core is ocean engineering, I still had to learn all the rest of the engineering going on. And there's a good reason for that, is because what you've probably heard from the whole panel here is that just because you come out as an ocean engineer doesn't mean 2 or 3 years later you're going to be an ocean engineer. You really come out as an engineer. And I kind of come back to my own experience here at GM, working. I have very few system engineers working for me. I have a lot of mechanical engineers. I have a lot of electrical engineers working for me. I have someone from biomedical working for me. She's trying to solve cancer, the cure for cancer before coming over to my team. You have people who are just really good at what they're doing for computer science. Now they're working for me as a system engineer. And the reason we can do that is because in college you just don't take your core engineering course. You take the whole spectrum. You even go through business. There's business in engineering. And learning if your project's going to be successful or not based on how much revenue you get out of it, and how many resources you put in. So at the end of the day, you're going to see everything coming out, and you're going to be a well-rounded engineer when you get out.
All right. There's another one.
What's the daily life of what you do as an engineer?
Okay. What's the day in the life of the engineer?
I'll grab that one first and then go on. It entirely depends on what happened with the customer the day before for me. I have a list of stuff that I'm working on. For me, it's, we're trying to get the system working on new vehicles every day. And then I've got software issues that we're testing. And then I might have a customer call with a problem. And I might be on a plane tomorrow, tonight, to fly to that customer to look at the issue. But that's more my role, which is customer focused.
Raghu, you want to?
Sure. I think for me, when I was in my job, focused on engineering type of an activity, because I've done several different roles in BASF now, I would say back in the day it was all about customer problem solving, like you mentioned. We were focusing on, I have an interesting example. One of my customers, they used to sell the roof insulation, which is basically, if you look at this roof, for you to have insulation in this room, you'll have like a material protecting you on top of those ceiling tiles. So we had a problem with one of those situations, and the customer's like, the product you gave me is not functioning, it's not insulating properly. So you have to solve the problem right away. They give you, okay, can you tell me why this material is not working for me? So then you jump right in and you work on it. Another problem-solving issue was with Ford. We had an issue with Ford headliner foam, which is basically, if you look up in your car, there is a foam above you. That's also a material we supply, and that material, if it is not flat, if you look up in your car, it should be flat. If it is somewhat warped or if it's curved, then it's a problem. So Ford, they had an issue. Again, jump right in. We have to understand what the problem is. So for me, a day-to-day engineer job is about problem solving and figuring out the knowledge you have acquired, how you can apply to practical situations. For me, that's the crux of being an engineer.
Probably to add to that, there is no typical example of daily life. When I was young, you'd work out there and say, I'm putting instrumentation on a vehicle, I want to measure temperatures and pressures, go out on the test track and try and break that vehicle, it's great. But then later on you start to manage more projects, you start doing work on engine combustion systems, and you're looking at the emissions of that and measuring a lot of engine performance data and then calibrating that to change the performance data. And then you get a little bit older and maybe wiser, I'm not sure, but then you start looking to manage and mentor other people and bring in junior engineers and teach them how to do engineering, how to be better. And you learn all the way through, and again, apart from the problem solving, the other daily aspect is learning. You're always learning.
Yes.
I would also like to add an element to that question. What does a day in my engineering life look like? So I drove my career in the meanwhile more into a general management position. And I'm still working for that tech company ZF, which means we bring up a lot of new technology and we bring up a lot of new product. I'm not inventing that myself necessarily because we have the engineering teams doing that. But in that general management role, I appreciate so much that technology. So this morning when I went into one of our electrified trucks with a new, much more efficient propulsion system, that's when really the engineer comes out in me. Yes, I'm not engineering that, but I still want to understand what do we put into product, at what cost does that come? That's another thing. What resources do we spend, both on the material side, on the cost side? How many engineers do we really employ to make that electric truck happen? So there is a full field, an endless field of activity that you can start getting into as an engineer. I have more questions. That's even better than our prepared ones.
Real quick, just want to add one more thing to the daily life part. Is you have to understand, as an engineer, again, it's a mindset, right? And it's a character, it's who you are. And you grow up with other engineers with the same mindset. And any job you take, when you go into the workforce, you understand that gets you up in the morning is solving the problems, but it's also your coworkers who you deal with. The last thing you want to do is wake up in the morning and say, I got drama to deal with today. with Jill or John, fighting going into hysterics. You don't get that from engineers. Engineers are fairly level-headed creatures. They're very logical. They have the same mindset. They really want to get down and solve that problem and work together as a team. So when as an engineer, overall, the atmosphere of the workplace, I found is so much better when you get out there. And when you think about day-to-day grind, that's what you're really looking for.
When you think about your engineering projects, Carrie, how do they look like? How do teams get together? I mean, you go in charge of these battery packs. It's pretty novel, right? It's a pretty big deal.
Yeah, I mean, I guess I'll go back a little bit in time because now I work more in management, so my job is a lot about program management and guiding my team and training the young engineers and making sure they have the tools to be successful in their jobs. But when I was a young engineer, a lot of my day starting in batteries was really hands-on. So this is a pretty automotive industry heavy panel given that we're in Detroit. So I got to spend a lot of time hands-on working on cars. And in that time, was really in the infancy of the, let's say, mass-produced vehicle electrification. So the majority of my time was spent working on cars, testing cars, driving cars, calibrating. I got to go on a lot of really fun trips, taking them to Death Valley in the summer and make sure that the batteries still work, taking them to Colorado in the winter, taking them to northern Canada in the winter where the air temperature is -20 and making sure that the cars still work. I drove electric cars across the country. And that stuff was all part of what I did basically as a young engineer, making sure that the system worked, the product worked. Now I'm a little more involved in the business end, so working for a large automaker. We have some big battery production plants that we're building, and so highly involved in these kind of joint ventures between auto companies and battery suppliers. Building enormous factories to produce the next generation of electric vehicles. So, my schedule varies day to day. I also spend a lot of time traveling around the world, so that's a part of my job that I enjoy. So. Yeah.
Let's take one question that you submitted. How important is IT? How important is programming computers nowadays in engineering?
I can continue, even though I'm a chemical engineer, and that's probably not associated that much with programming. I did spend a few years of my time writing software code on how to properly control batteries, so that was one of my, even though I only ever worked in batteries in my career, I did work in various areas of that, including software. Coding is kind of everywhere, so a lot of our engineering is done in MATLAB, that's coding. I highly encourage everybody to study coding. Again, it's not intimidating. It's just like if you can study a foreign language, if you can study English, you can study coding. It's not any different. It's just another way of communicating. So.
Chris, how do you see that? With the mechanical electrification, working for a propulsion company, what role does software play?
There's so many analogies between different parts of engineering, and coding and IT is just another aspect of it. You always look at the requirements, turn those requirements into specifications, make something, check against the specifications. It's the same in coding. You really start out with strong requirements, turn it into lines of code, which is effectively writing your logic thoughts into a sequence of instructions that can be followed. And you need the tools, and as vehicles have evolved more and more, then you're always looking to use those systems to help your mechanical systems do better. You're taking away some of the uncertainty by improving the controls. And even if you don't have sensors, you can use controls to give you virtual sensors. So to do all of that, you need power electronics, you need processing power, you need lines of code. All of that comes together and all the systems work together because you put those requirements down in the first place.
Okay, I saw there were more questions.
So I have a question for Mr. Johnston, also any of those who have talked about that engineering mindset. So for me personally, I've always been more of an analysis person versus approaches. So for example, in physics, I like more thinking about why things are how they are versus like
Okay, so there's the question, how about being more on the analysis side when it comes to science, right? And understand what's happening, to the creation side that us engineers talk about as well. So if you are biased more in saying, I like the analysis, is engineering a job for me? Or?
Failure analysis. Why did it break? When the customer calls and says, this is broken, why did the gear break? Why did the code break? Why does the battery not deliver the life we expect? That is the other half of engineering, is figuring out what broke, and then how do you fix it, how do you make it better so that it doesn't happen again. That's absolutely a huge part of engineering, because you have to understand how they put it together in order to figure out what broke and how to make it better.
Yeah, you want to?
Yes, analysis capabilities, I say is an integral part of our engineering, right? I mean, for example, for product development, we really need analysis to understand, like you mentioned, right? And what's the feature, right? Why the feature works, those things are the analysis and to guide for product development. That's the first step, right? Conceptual. When you design product, the first thing you say, okay, what's its function, right? What's the feature support those functions? And we need those analysis capabilities. And then I think you were talking about then, at the second part of the execution, right, making the part, then we have different disciplines like manufacturing but analysis is, to us, is like a fundamental part of engineering. It's not just about just making things, but also how, right? How do we improve it? How to make it meet the requirements? So that's a part of analysis capabilities.
So analysis is extremely important. We've heard that over the spectrum here. And when you go to analysis, all engineers do that first, and they build requirements, and then they go to spec, and then they test them out. And that's the process when we look at engineering. When you look at, talk about research like in college, you're talking about like pure science. And that's valuable as well. When you look at what's happening out in fusion, right? So we're trying to figure out fusion. It's probably another 20 years out. But around the world, we're trying to do that research and analysis and understanding that's not necessarily engineering. That's research and science. The key part of engineering, and we're excited about this, is when we get that science and it comes to us. And as engineers, we take that and we build the reactors. We build the power plants. We start powering the entire world based on that. So if you look at the pure science point, being a scientist, that's absolutely essential. We need that because that's where engineers build all their formulas, all the bases off what the sciences work. And we bring it to the rest of the world so it becomes practical and usable. And so that's where you see the dividing line. Both sides are very valuable in order to bring technology and advancements to the world.
And another area of analysis is not everything's the same. You make 1,000 parts, those 1,000 parts are all different. You have to look at the variation. So everything we do in engineering always seems to have the word analysis in it. We have variation, simulation analysis. We look at things, how things can go wrong. Failure mode and effects analysis, how can you break it? You look at everything that you're doing in advanced engineering, we're using simulation and analysis. We're making digital twins of a real vehicle. So that vehicle could be going around the test track and doing something, feeding that model straight back to the cloud or to the edge, getting that information and running it through a digital twin. And that digital twin will explore different environments. It could be testing in Finland while the vehicle's actually in Arizona doing something. You can actually get this, and all of that is analytical work. We're using tools and disciplines to drive your engineering thought set. It's too expensive to make prototypes. We have to do it in analysis.
All right, next question.
There's a question there.
Just yell.
So, as a high schooler, what would you say is something we can do to show our passion in engineering, preferably other than robotics?
Okay. What can a high schooler do other than robotics, right, to show passion for engineering?
I can take that one. I think for me, I know robotics is definitely something a lot of folks you get involved in, but if you have certain topic, right, that is really of interest to you, just showing, okay, like what you asked, like why is this happening, and to understand why you have that problem, and maybe coming up with some kind of a solution on your own, even within one of your classes you're doing, you could pick something like that and to work with your teachers. I'm hoping that you could further investigate and do your own. I personally don't think, like going back to the very first answer I think we all gave, is go with your passion, go with your interest. If you have a certain interest in one of your classes that you would like to investigate further and work with, come up with a solution based on what you know. I think that is very important for, I think, colleges to see that you have a passion and you are pursuing something that you like.
What's your junior project again? The extended essay? That's it, right? When you happen to do that in science or maths or so, you're right on. You're researching something, you create something, right? You spin your thoughts out of an analysis, for instance. So the school is really giving you a very good instrument with that, if you want to experience, if you like it, and want to make that your profession.
One quick point. Sorry, didn't mean to cut you off. How many clubs does this school have?
Too many.
Okay. But there's an opportunity to create a club to explore what you're looking for, and if your teachers can support it, or any of us, be more than happy to volunteer in any of those to help you explore what that passion might be.
And think about the product as well. When as an engineer, you have to know how to make something. So you can start saying, okay, I want to understand how to make something. So I've got a square piece of metal, how can I make it round? So you start investigating machining processes. And you can look at something, that's how it's made, you can replicate it, you can make things, you can do it with 3D printing, you can make the parts, you can make products and work with actually making parts and understand the mechanical aspects of how something works without having to get into the coding or the robotics. And then if you did look at robotics, you've got the coding aspect of it, but you've got the build aspect of it as well. You've got to look at how things go together. How am I going to fasten this to this? Do I weld it? Do I use a fastener? Do I glue it? Start looking at some of those aspects, or look at the chemical processes of something. And not everything is code. And actually, we prefer a lot of people to be more hands-on and actually working with materials and techniques than just with code. To be a really good coder and programmer, you need to know how the thing works. And the best analysis engineers and simulation engineers we have are the ones that have actually worked on product development on the product.
You want to give it a shot?
So going off one of the first few questions, we were talking about how there's a wide array of topics that you can look at, especially in high school. But more on like the college level, is there certain minors or things that you can look into and study that would not only be beneficial for your understanding of your major, like if I want to do aerospace, be materials as a minor be good, and is there any certain things that employers would look for and find as beneficial for any projects?
Okay, so we talk about college, undergraduate study, and the question is how can one first of all explore different areas, right, to determine what are my personal preferences? And then also your question was to the next level, when us as employers look at study at university careers, what do we look for? Who wants to go ahead? Jan? Ready to jump?
Maybe I can make something. I think like for team leaders here, right? When we recruiting students, we're looking for growth mindset, right? I mean, it's like we're not really just say, hey, your experience, you have all these classes, but we're also looking for the pattern, right? And you're based on initiative, you identify opportunity to prove yourself and learn different disciplines, right? I'm a mechanical engineer, but I think taking electrical course and help me for finish this design project. So that kind of the trends we're looking for, right? And, basically to show your passion and show your initiatives, and based on your own passion, that how do you manage to take in different classes to complement your passion. So that's kind of the trends we're looking for from a recruiting perspective.
And remember too is that you gotta look at the mindset of college, right? College, especially from probably a lot of people on the stage here, is a great way to get your leg up, get a career, have a good firm base, so you can have the 40 years, as an excellent contributor to society, right? And you'll get that as an engineer. But also, college is there for you to get the great understanding, the education that you want to get out of, right? So when you look at the major and the minor, yes, major in engineering, that's a good mindset. It'll set you well in life. But your minor doesn't necessarily have to be another engineering, okay? We talked about literature, right? We talked about Mandarin, different languages. Do something that you want to follow your passion with. I mean, the college, you're paying hundreds of thousands of dollars to go to this college. Really get something out that you want, okay? Something you're really passionate about. You know, if it's not your major, make it your minor. And I say like Mandarin, well guess what? I would love to have an engineer that could speak Mandarin. Send him to China, right? Or to Europe. An engineer that actually knows how to spell literature. I mean, that's solid gold, right? So make sure that you go through and you have the wide spectrum. You really get all the information that you can out of that college because you're going to pay for it. So make sure you get the most from it and enjoy it.
Just one comment I would like to add though, because he specifically asked for aerospace engineering and what major or minor I should take. I think I would focus on, if you're interested in aerospace engineering, what part of that aerospace engineering you want to learn more, right? Focus on that, because for me, it's all about learning. I know we all want to have great grades and great test scores and all that, but you have to learn. So you have to understand what part of aerospace engineering I'm really not understanding better. So maybe I should take a minor that will help me become a better aerospace engineer. Because parts of it are, let's face it, engineering, anything is multidisciplinary. Yeah. So you focus that way. You focus on your learning, because the more you learn, the more interested you become, and that will really drive your passion.
And just think again of the analogies. Is you think aerospace engineering, so what's special about that? People say, well, aerodynamics. Hey, we do a lot of aerodynamics just in the engine side. Air has to enter a turbocharger, has to spin around at 250,000 RPM and then come out into the engine. You've got piston coming up. Aerodynamics is really important just inside the engine, let alone outside the vehicle. You've got control surfaces on planes, you have control surfaces in automotive. So,
one of the things,
coming back to the CV,
if I'm looking down a resume and I'm looking to take an intern on,
I scan down, have they done Formula SAE?
shows commitment.
Or have they done SAE Baja, which are two team-related project activities, and that really says that's a good intern to go for.
You said a key word, internships.
Yeah. Oh, yeah. Sorry. Yes.
Do them all.
Do as many as you can.
Good. We have about 5 minutes left, I understand. Good. Then let's take us a bit into the future. And having such an experienced panel here, where do you see engineering go? What is in demand? What should our students really anticipate when they prepare?
Well, I'll start for that one real quick. Everyone's read the news. Everyone knows right now that the best way to write a paper is through AI, right? You go through, I want this, comes out, you got 15 pages, you're done, you turn it in. Right? Yeah, I just read this morning that they did this through Wharton Business School, University of Pennsylvania, probably one of the hardest schools in the country to get through. And they gave it to an AI, and the AI got a B+ and was able to get through it, right? So, and that's literature, that's business. Right now, if you're in the stock market, they've actually proven that a stockbroker can no way write better than an AI when they come up to describe a stock. Okay? So that job is kind of out now. When you look at engineering, you can't get AI to really do engineering for you, okay? Because every day there's a different problem. Every day you need to come up with a different solution. If you look at what AI is doing right now with these papers, I guarantee you there's probably about 50,000 papers out there on a specific business topic that Warren put out. 50,000 papers, you put it in a computer's going to figure out how to make another paper out of that. When it comes to engineering, there's 50,000 different questions about what happens and how to solve it. And AI can't figure that out. Okay? Only the human brains can be able to push that into the future. So if you're looking at, what you look at for, your stability as an engineer, you're always going to need engineers, no matter what. So I think in that regard to the future, you're pretty much set to choose this path.
Good. AI, though, an important field. Let's hear from the chemical engineers. What's happening?
The future I want to say the future of engineering is you guys, the young people in this room, right? It's the next Steve Jobs, it's the next Bill Gates, it's the next Elon Musk. I mean, 20 years ago when I went into engineering and I said, I'm going to be an electric car engineer, everybody told me I was crazy. They're like, no, you're going to be an unemployed engineer because nobody's going to make electric cars. And I was like, nope, I'm going to do this. I love it. This is what I want to do. This is going to be the future. I'm going to study this. And of course, you know, it turned out that I have one of the most in-demand career paths out there. I mean, we can't hire enough battery engineers. I would, you know, hire 5 tomorrow if I could find them. And so I think one of the things that led to my own personal success in my career is just having a really strong passion for that. So, you know, I know some of your parents are in the room, so, you know, you guys cover your ears, but it's, you know, don't always necessarily think about financial gain as 100% of the goal. You need to also follow your passion in terms of you can't do something that you hate for 40 years. So
Got to enjoy it.
That was a good personal advice. And maybe that's how we conclude the panel. Let's go down the row once more, and we heard from you, Carrie. Jan, what's your final word of wisdom and advice to the students when it comes to considering an engineering career?
You know, my advice is, you know, keep your eyes open, right? The growth mindset, and if you see something interesting to you, and dig deeper. You know, you might find, you know, things like find your passion for those. So, you know, a simple word is like keep your mind open, and have a growth mindset. That's it.
Yeah. Chris?
Be aware that, and you'll hear this so many times during your career, but the only constant is change. Everything is always changing, and you have to be ready to adapt to that change and plot your career to be capable for that change. I'd say if you are looking to do combustion engineering and engine engineering right now in light-duty passenger cars, don't, because electrical engineering is really the way. But there's still, you have to plan for those changes, be aware of where the market is going, and adapt and be ready for that market so you're always in demand and always enjoy it.
And just remember, you need materials everywhere. So the need for materials is always there. But I think, going back to this particular comment, though, I think for me the future, I don't think any one of us can predict the future, obviously, but always remember, be flexible. Learn as many different things as possible within your different fields, right? You're too young to be focusing on just one aspect of any subject, in my opinion. Just focus on whatever subject you're learning, focus on multi-facets of the subject, and see how they actually intermingle. Like, how is chemistry overlapping with physics? How is physics overlapping with biology, right? There are a lot of these overlaps that a lot of people don't even think about. Be flexible, be open-minded, like you said, have a growth mindset, echoing everything they said. And always remember, you have I think nobody really knows where this will eventually lead to, but like you said, you need problem solvers, you need thinkers, you need solution providers, so.
This my parting shot is engineering is at a great base. You can always count on that foundation. I've always been told in my career, stay in until you love it. If you don't love it, get out. Right? When you have an engineering mindset, if you don't love something, get out of it. Okay, move on to something else. But being an engineer allows you to do that. It gives you a background. It allows you to branch off to anywhere you want to go. I talked to a lot of CEOs. They said, well, I just hired him because he's an engineer. Well, what type of engineer? I don't care. He's an engineer. We just want that kind of people on my team. So going forward, it's not just engineering. It's whatever you do. You don't want to be stuck in a 40-year job, punching the ticket. All right, that's why all of you are here at IA. You want to give yourself the opportunity to do whatever you want, no matter what that is. Make sure you keep that up. Go to the college you want, okay? Make that career that you want. Keep doing what you want in the end. You only have one life. Make the most of it and really just enjoy it, whether that be engineering or anything else.
no matter what you decide to do, for me it was say yes to every good opportunity that came along. You don't know where it's going to lead you, but it's turned out pretty good for me, so I've enjoyed the ride.
And I'll keep it short too. Do what you enjoy doing, right? You will enjoy that even more. And hey, if it happens to be engineering, there is endless opportunities, so go grab them.